Okay, so we're going to review slope-intercept form for graphing a line and an inequality, because we're going to also be doing some shading for this type of problem, but we can still use the basic slope-intercept form. Even though it says equals, it's still graphing the line in the same way. So with this one, and it's, I know, very colorful and kind of silly looking, I wish it would print in color on your notes pages, but it'll at least be on the screen this way. So y equals mx plus b. So y is our output. So that's our, what we get once we have our x to input. Our slope is the m. So this is the vertical change compared to the horizontal change. And then b is our y-intercept, where the line crosses the y-axis. And this is where we start our graph. So we always start at the y-intercept, and then we use the slope to find a second point on that graph. And we can use these in different ways too. If we were given, y and x like a coordinate and a slope, we could plug them in to figure out what the y-intercept is by solving, things like that. So we can use this in different ways. A lot of the time we're using it because we can very easily grab our y-intercept and our slope. So if we take a look over here, we have the equation y equals -2/3 x plus 4. So crosses the y-axis at 4. So you can see they have this y-axis here, right here, and it's that little orange dot. It's at 0, 4. And then the slope, which they brought down here, and they're showing rise over run. So they're showing that it's -2 and +3. So this is a drop of 2 and a run to the right of 3, because it's +3. So they're going down 2, right 3. If you didn't have enough room to go down 2 and right 3, you could go backwards from that. You could go up 2 and left 3. As long as the negative is only given to one of them, it's perfectly fine to kind of switch it if you need to. It just depends on the area on your graph. So they went down 2, right 3, and they landed right here on 3, 2, so that's a second point. And they put it down here again, the b equals 4, which is the y-intercept. So they were kind of showing that. Oh, you know what? I think I cut that off from right here, so it was kind of a repeat. That's what happened. So this is the graph of the line. So we're going to do that, and then we're also going to do some shading. So to graph an inequality, we use the slope-intercept form, which is the y equals mx plus b, and we just went over this. M stands for the slope, and b stands for the y-intercept. We always start with the y-intercept, and then use the slope for the second point. So again, already went over all of that. That's just kind of saying it again in written form instead of just verbally. So let's go ahead and graph this line, and then we'll deal with the shading. So I have y equals mx plus b right here. So what is the y-intercept? Well, that's going to be the -1 right here. And then what is the slope? Right here is the m, so that's the -2. So we have our 2 points we can graph. So we're going to start with our y-intercept. We're going to go down to -1 and put our point. And then for the slope, it's rise over run. So remember, this is -2 over 1. If I don't see anything under the number, it's a 1. So I'm going to go down to right 1 and put a point. And now I need to decide, is it a solid line or is it a dotted line? And so that's another thing that we've reviewed here in the past couple of weeks. If I have it greater than or equal to or less than or equal to, it's going to be a solid line because of that equal to part. That makes it a solid line. If it's just less than or just greater than, it's a dotted line. And the difference visually is just letting you know that the answer is included or excluded. That's all that means. So it just lets us know, is it a starting point and I'm going to go above or below that, or can I actually grab points on that line for part of my solution? So I need to change the color of this line so you can see it a little better, but it's a white line going through here, and it's a solid white line. It looks a little bit like it's dotted because of the blue is playing tricks on your eyes a little bit there. So now, to figure out am I shading above or below, you pick a test point. And 0, 0 is a really easy test point to do. As long as the line's not going through 0, 0, then you can pick that one. So if I have 0, 0, remember this is x and this is y. So I'm going to go y is 0, which is less than or equal to -2 times 0. And I put plus because that's part of the equation, plus b. So plus, and then it's -1 because that was what was actually there. So now I'm just going to reduce a little bit. So I have 0 is less than or equal to -1 because this becomes 0 and anything plus 0 is itself. So now we're just deciding, is this true? Is 0 less than or equal to -1? Well, no, that's not true. 0 is not less than or equal to -1. So that test point failed. So what it means is I'm jumping to the other side of the line. So if the test point passes, that means I'm going to shade on the side that that point is on. If it doesn't pass the test, then I go to the other side. The other way that you can think of this, and I think it's a little easier to think of it this way, what you do is you go to your y-intercept and you look at the inequality you have, and if it's less than, you go below that. So you can see if I go below, I'm in the red. If it was greater than, I could go above and I would be up in the area that's not currently shaded because that's not part of the answer to this question. So it's just another way of doing that. Same idea. You can choose a test point and is it true or false, or you can just look at the y-intercept and go above or below that point. So it's just another way of doing kind of the same thing there. So that was reviewing the slope-intercept form of a line, using it for inequalities. So I hope that helped, and I will see you in the next video.